Namaste students, myself Sunil Kumar from the Department of Computer Science. Today we are moving to next session based on the chapter data representation. In the last session we mainly discussed about the number system conversions. If any number is given, how we can convert to another number system. Mainly we discussed about decimal to binary conversion, decimal fraction to binary conversion and binary to decimal conversion. All these three types of conversion we studied or we discussed in the last session. And if you are going to move to our session in today's session, and in this session also we are going to continue the same topic, conversion, number system conversion, because there are different types of number systems are there. There are mainly four types of number systems are there. One to another means almost all will get 16 types of conversions. Almost will get 16 types of conversion we are getting in case of number system conversions. Already we discussed with the three. One is decimal to binary, decimal fraction to binary and binary to decimal. Means decimal to other conversions are O. Next here is decimal to octal conversion. In this session we are mainly discussing about decimal to octal conversion. Whenever decimal is given means how we can convert that octal conversion. The first step, or if you want to convert any number, some procedures are there or some algorithms. We will normally say algorithm, or you can say some procedures or some rules and regulations. Some procedures will be there to convert any number. The first here is divide the given number by 8. First step. If any number is given means we have to take the number and we have to divide the particular number by 8. In case of binary to, in case of decimal to binary, we are dividing by 2. We are dividing by 2, but here we are dividing by 8. You have to divide the number by 8. Then after dividing, then you have to know the quotient and remainder. You have to know the quotient, then remainder. You have to write down the quotient and remainder. Step 3, third step. Steps 2 and 3, 1 and 2 should be repeated. Repeat the step 1 and 2 until the quotient becomes 0. Whenever quotient becomes 0, until that we have to repeat the steps. Until that we have to repeat the step. So means first you have to take the number, divide by 8, note the quotient and remainder. Once again take the that number, take the quotient and divide that by 8, you will get the quotient and remainder. So divide by 8, quotient and remainder, divide by 8, quotient and remainder. So this will be repeated, this should be repeated. These two steps should be repeated until the condition quotient becomes 0. Quotient, when it is 0, until that we have to repeat the number. Then first remainder will be the LSB. Next what we have to do is first remainder will be the LSB and last remainder will be the MSB. Remember LSB and MSB. LSB means least significant bit. MSB means it is the most significant bit. There are two terms are there. Already we discussed about this one. One is least significant bit. One more is most significant bit. Least significant bit means we take one number. It is a 110. If you take the 1101, then in that case the first bit of a number is known as most significant bit. The first bit of a number is known as most significant bit and last bit. When you are going to see the last bit, that last bit is known as least significant bit. Remember, most significant bit and least significant bit. For example, take the 523. If your number is 523, 5 will be the most significant bit and 3 will be the least significant bit. 523. So like that, you have to mark the LSB and MSB. See here, first remainder should be the LSB and last remainder should be the MSB of your number. So this is the procedure. If you see the procedure, same procedure already we discussed. The same procedure we already discussed with one more method. That method is decimal to binary. When you are going to convert decimal to binary, same steps are used, but you have to divide by 2 in that case. But here we are going to divide by 8. See one example. We are going to see one example. In this example, number is given at 459. Number is given at 459 base 10. Whenever base 10 is given means you should understand that that is a decimal number. Based on the base values, you have to understand that number belongs to which term. So here base 10 means is a decimal number system. So this decimal number system should be converted to base 8. Base 8 means octal. Base 8 means octal. Remember, base 2 is binary, base 8 is octal, base 10 is decimal, and base 16 is hexadecimal number system. So we have to convert that numbers. We have to convert. So steps are already given. So we have to repeatedly divide by 8. Simply we can say that it is a repeatedly division method. Repeated division method. So we have to first mark 459. Number is 459. You have to divide by 8. You have to divide the number by 8. When you are going to divide the 459, you will get 57. 57 points. The fraction values. Actually, we don't need the fraction values. So we will get the remainder as 3 here. We will get the remainder as 3. Then once again take the 57. So first step is over. First take the number and divide by 8. First procedure step is take the number and divide by 8. We will get the quotient and remainder. We will get the quotient and remainder. Two steps are. Next step. Repeat the step until the quotient becomes 0. So repeat once again. Divide by 8. Divide by 8. It will be the 7. Number is 7 and remainder will be the 1. Remainder will be 1. Then once again repeat the step. Divide by 8 because the quotient is not 0. Here quotient will be 0. Remainder will be 7. Quotient is 0. Remainder will be the 7. So whenever the quotient is 0, that division should be stopped. Dividing the number should be stopped. After that, it is given that first bit, the first bit is LSB. First bit, first remainder is a LSB and last remainder is MSB. Remember that the first remainder is this one, last remainder is this one. First we got this, next this one, last this one. So first remainder should be the LSB and last remainder should be the MSB. So we have to mark the number from down towards up. We have to mark the number. So 713. So you have to write the number. First is 7. MSB should be 7. Next 1. Then 3. 713. So 713 base 8. So normally you are writing it. This 713 base should be written. 713 base 8. So this is a conversion from decimal to octal. I think you understood. See one more take. We'll take one more example. One more example. 723. 723 base 10. Whenever base 10 is given means that number is decimal number. Whenever the number base is given as 10 means that is a decimal number. That decimal number should be converted to octal. That being your octal. Or sometimes they will give as base 8. You have to convert that to base 8. Base 8 means you should convert to octal, or sometimes they will give to octal. So take the number here. 723. Take the number and divide by 8. If you are going to divide the number, we will get 90.375. So 375 is not required. So you have to mark the remainder. The remainder will be 3. Remainder will be 3. The next once again take the number, divide by 8. 80 divided 90 divided by 8. You have to divide the number once again 8. It will be the 11. 11 into 8 is 88. 11 into 8 is 88. So 2 will be the remainder. 2 will be the remainder. Once again divide by 8. Divide the number once again by 8. So here 8 once again 8. Remaining is 3. Once again 3 is remaining. Once again 3 is remaining. Once again divide the number by 8. Once again divide the number. You have to repeat the steps again and again. You have to repeat the steps again and again until this quotient becomes 0. Until the quotient becomes 0, you have to repeat. Then here will be 0 and quotient remainder will be the 1. Here remainder will be the 1, quotient will be the 0. So whenever quotient is 0, then you have to move to the last step here. First remainder will be the LSB. So here first remainder. This is the first remainder. So you have to mark this as LSB and last remainder will be the MSB. Last remainder will be the MSB. So this one is MSB. So we have to take the number from MSB to LSB. MSB means it's the most significant bit. LSB means it's the least significant bit. So from the most significant, MSB is the first bit and LSB is the last bit. Like that we have to mark the number. It is 1, 3, 2, 3 base 8. It is 1, 3, 2, 3 base 8. This is the number. So octal number is equal to octal number is 1, 3, 2, 3 base 8. This is the number. So remember that one. When you are going to write the number, you have to write the base values. Don't forget to write the base value. Based on the base value only we are understanding. Otherwise, it's not possible to understand that number is belongs to which type. So remember that when you are going to convert the number or when you are going to write any numbers, you have to write the base values. Here 459 base 10, so it's a decimal. Here 723 base 10, so that is a decimal number. 328 base 8 means it's a octal number. Here 713 base 8 is also a octal number. So based on the base value, we can understand that the number is belongs to which type. So here we discuss about decimal to octal conversions. Now we will move to the next type of conversion. The next type is octal to decimal conversion. Octal to decimal conversion. Already we discussed about decimal to octal. Decimal is given means how we can convert to octal. That is right already. Here is octal to decimal. Whenever octal number is given, whenever any octal number is given means how we can convert that octal number into decimal format. This is the one more type of number conversion. So this type is already we discussed. Whenever any binary is given means how we can convert to decimal. Already binary number to decimal we discussed. Same method should be followed in case of octal to decimal conversion. See, already we discussed octal to decimal conversions, or we discussed in whenever we are going to write the positional weights. When you are going to discuss the octal numbers, I already told this method. How to write the positional weights? Based on the positional weight, we can find the actual value. Based on the positional weight, we can find the actual value. So already I discussed this one. So once again I am explaining same thing here. How to find the decimal number of a octal. How to find the decimal of a octal number. Multiply each. Here also one procedure is there. Here also one more procedure is there. The procedure is simple procedure with only 2 steps. The procedure is multiply each bit of octal number by its positional weight. Multiply each number or each bit of octal number. Octal number contains only 0 to 7 symbols. So 7 symbols are there. So any number is given. For example, 432. 432 is given means each bit first we should take, then 4, then 3 and 2. Like that you should take all the number, all the bit, and you have to multiply by its positional weight. The positional weights are start from 0, 1, 2, 3, 4 like that. The positional weights are starts from 0, 1, 2, 3, 4 towards left. Towards right is -1, -2, -3. Like that positional weights are going to move. From the starting from the decimal point. Is a decimal point means towards left side 0, 1, 2, 3 and towards right side -1, -2, -3. Don't forget that one. So normally from starting from this one, don't write 1, 2, 3. It is a 0, 1, 2, 3 positions. Towards left side not 0 is not there. It is a -1, -2, -3. Like that you have to have the positions. Then based on the position weight we have to multiply. Then you will get the product. Then all the product terms should be added. All the product will be added, you will get the final value. That will be the answer of decimal or octal equivalent or decimal equivalent of the octal number. So here is one example. We will move to example. Example is given at 234.56. 234.56 is the number. If you give the 23456, you have to write the numbers here. 234.56. 234.56. This is the number. If this number is given, then you have to write the positional weights. Here it is a fraction. So from fraction towards left side, it is 8 to the power 0, 8 to the power 1, 8 to the power 2. Like that, you have to mark the number. 8 to the power 0, 8 to the power 1, 8 to the power 2. Normally, you should like that. Some, when you are going to write the exam sample, you will get confused because 0. Normally, you write 1, 2, 3, minus 1, minus 2. You will get to forget to write the 0. Don't forget or remember that one. Always, when you are going to write the numbers, position weights start from 0, 1, 2, 3. Not 1, 2, 3. The position weights start from 0, 1, 2, 3 and towards right side is minus 1, minus 2. Minus 1, minus 0 is not there in that case. When you are going to write the right side positions, here not minus 1, it is minus 1, it is 8 raised to minus 2. Here 0 is not there. Remember 0, 1, 2, 3, 4 like that. Towards right side is minus 1, minus 2. Here towards right side minus 1, minus 2. Towards left side 0, 1, 2. Here remember that. Sometimes you get forget right minus 0 here. You write 1, 2, 3, 1, minus 1, minus 2. So if you write like that, you will get the wrong answer. Remember 0, 1, 2. Position weights always start from 0, 1, 2. Towards right side is minus 1 and minus 2. Here is a number. Then 8 to the power 2 or 8 raised to 2. 8 square is 64. 64. Then 8 to the power 1. 8 to the power 1, it will be 8. 8 to the power 0, that will be 1. Because if you multiply, if you take the power of any number with the 0, 2 to the power 0 is 1. 3 to the power 0, that is also 1. 8 to the power 0, that also 1. 16 to the power 0, that also 1. Any number power 0, that is actually the 1. Then 8 to the power minus 1. If 8 to the power minus 1, we can find the minus 1. If calculation is there, we can calculate this and so easily find the 8 to the power minus 1. Otherwise, one more method. 8 to the power minus 1 is equal to 1 by 8 to the power 1. So 8 to the power 1 is 1 by 8. You have to divide the number. It is a 1 by 8. So 1 by 8 is 0.125. 0.125. So whenever 8 to the power minus 2 is given, 8 to the power minus 2. 8 to the power minus 2. So 8 to the power minus 2 it is 1 by 8 square. Means 1 by 64. 1 by 64. So, normally, only for exams, normal calculator is allowed. Scientific calculators are not allowed. So, whenever, if you got these type of numbers, how we can convert? This is the method. This is the step to convert the numbers. 8 to the power minus 1. 8 to the power minus 1 is 1 by 8 raised to 1. So, 1 by 8. 1 by 8 is, you can see why calculated is a 0.125. 8 to the power minus 2. 8 to the power minus 2 means 1 by 8 square. Minus will go, so it will be 1 by 8 square. It is 1 by 64. 1 by 64 it is 0.03125. 0.03125. This is the number of 8 to the power 2. 8 to the power 2 is 0.03125. So if you got like this number, then you have to write the numbers or you have to find the actual value. So take the first number. Normally it is given that multiply each bit of octal number. So each bit, first bit, second bit, third, fourth, fifth, 5 bits are there. Each number, each bit with its positional weight, its weight is a weight value. So 2 into 8 to the power 2 plus 3 into 8 to the power 1 plus 4 into 8 to the power 0 plus 5 into 8 to the power minus 1 plus 6 into 8 to the power minus 2. So like that we should write the number 2 into 8 to the power 2 plus 3 into 8 to the power 1 plus 4 into 8 to the power 0 plus 5 into 8 to the power minus 1 plus 6 into 8 to the power minus 2. If you got this number, then you have to solve. When you are going to solve, it is a 2 into 64 plus 3 into 8 plus 4 into 1 plus 5 into 0.125 plus 6 into 0.03125. 0.03125. Then going on solving, you will get the 1 decimal number. You will get the 1 decimal number. That is the equivalent of the octal number. That is the equivalent of octal number. Here it is 156.71875 is the number. If you want to solving this one, we will get the number 156.71875 is the number. This is one example. Take one more example. How you can convert one more? If you want to understand one more example, small example. Example 63.21. You should write 63.21. 63.21. This is one more example. In the example, starting from octal fraction or octal point towards left side. Dot mark. This is 0th position. 8 to the power 0, 8 to the power 1. 8 to the power 0 and 8 to the power 1. Towards right side, 8 to the power minus 1, 8 to the power minus 2. 8 to the power minus 1 and 8 to the power minus 2. Remember, 0, 1 is not 1, 2. Here minus 1, minus 2 is not 0, minus 1. So towards right side, it's a minus 1, minus 2, minus 3, minus 4, minus 5. Start from minus 1. So towards left side, it is a 0, 1, 2, 3. Not 1, 2, 3. It's a 0, 1, 2, 3 like that. Dot mark the number. Then 8 to the power 1, it will be 8. 8 to the power 0 is 1. 8 to the power minus 1 is 0.125. 8 to the power minus 1 is 0.03125. So I got practice to write the numbers. So this is the 0.3125. So practice how to write the fraction values. So it will be a 0.3125. That is a 8 to the power 2. After that, we want to find the actual value. When you are going to find the actual value, first take the first bit 6 into 8 to the power 1. First bit into 8 to the power 1 plus second bit 3 into 8 to the power 0. Second bit 8 to the power 0 plus 2 into 8 to the power minus 1. Third bit into 8 to the power minus 1 plus 1 into 8 to the power minus 2. 1 into 8 to the power minus 2. So we are going to solve this one is 6 into 8 plus 3 into 1 plus 2 into 0.125 plus 1 into 0.30125. Then go on solve it, you will get the one decimal number. I am not going to solve these numbers because it is difficult to solve. So if you use the calculus, directly you can solve the number and finally you will get the one answer. That answer will be the decimal number. That answer will be the decimal number, and for that particular number you should write the base value as 10. So we reached the end of our session today. In this session we mainly discussed about converting octal to decimal and decimal to octal number. If any decimal number is given, how we can convert that into octal? Whenever any octal number is there, means how we can convert that octal to decimal. Two conversions mainly we discussed in this session. Remember that one, there are more than 16 conversions are there. So if you got any conversions, convert and practice that particular conversion, then practice it, then you will get easy. Otherwise, if you get not practicing any conversions, later on it will be difficult for you because there are more than 16 conversions on there. More than 16 conversions will get confused with the other conversions. Remember, the conversions are important and you get the full marks based on this chapter. So I will wind up my today's session. Thank you.